Okay, so last week we had a look at we just tried to mess around in Houdini and see how it works. But this week we're gonna have a look at regarding the rigid body simulations and fracture. This week we're gonna talk about rigid body simulations and material-based fracture. So if you just want to do the same thing that you did last week, you can have an object, move it up, rotate it, and just click on the shattering. You don't need to follow me on this part, but I just want to go through that to show how to so you shatter it, you make it a rigid body, add a ground, and it just your box shatters apart. But what are these? What are these nodes? Okay, what's happening underneath? So we're not gonna. It's not a toy. It's an actual program that we want to make large scale simulations. So I need to know what happens. So let's start from Maya. Actually, many of you do your modeling within Maya. I want to do a modeling inside Maya. Take it here and add some fracture on it. I make a simple model like a pot or like a jar or whatever. I can do it in Houdini, but just because for the sake of pipeline, the way the pipeline works, the pipeline procedure, I do it here so you know that. So in Maya, many of you do some modeling. So I just do a very simple curve-based modeling in Maya. So let's start from, I hold X here. Let's start from here. So that would be like hold X here as well. Okay. Press enter. This is just a very first year simple modeling, isn't it? So I'm fine with that. Yeah, nice. I did it double-sided because I want a thick layer of, and then I go and turn it into a geo. And you know that this geo is a NURBS surface. So if you look at here, so it's a NURBS surface, which is an algorithm, it's not polygon. Okay, so that's why I like to convert it to a NURBS to polygon. I go to the setting. I want it to be quad. I want to use poly count. Apply. I get a polygonal that is a bit jagged, but if you press 3, it somehow looks like that one. If you're not happy with the result, you can play around with the attributes here. But I kind of happy. I can apply a bit of smoothness to it as well. Shift right click, smooth. How many? It's good to have an idea of how many. So go to the display, heads up display, poly count. These are the stuff that you already know. This is 750 faces. I like that one. I move it back. I can keep these two. I group them, call them source. But this one, and hide them. And this one is the object that I want to send to Houdini. I call that, I don't know, pot or cup. It's like a pottery or whatever, cup, as Lucy said. Okay, so it has a history. I like to always clean the history, Alt-Shift-D in Maya. So, okay, we're ready. I export it out as, let me have a look, as if the poly, yeah, everything neat and clean. I export it out, export selection as, okay, where should I export it? I export it on desktop for now, but I will relocate it soon. Pretty much like what, so you start your Maya, so I should have started with creating a project. I was just lazy, but you know that you start everything in Maya with either addressing, so like pointing to a project folder or making a project. So in Houdini is the same. So we start with a project, or as Houdini calls, a job. So go to the file, new project. So on desktop, I remember that we made a project folder, did we? Oh, okay. So I make a Houdini projects here on desktop, and okay, inside that, you see that inside desktop Houdini projects creates Houdini projects again. I don't like that, so I just want desktop Houdini projects, and this one is rigid body fracture, or whatever you like to name it. Okay, so here you see that how Houdini categorizes stuff. So like geometries goes here, digital assets goes here. I kind of like to create a folder called imported. In all of my scene structures, you will see such a thing. It means I use that to communicate with other software. I like to create a folder called scenes as well. So when I press accept, under edits, alias and variables, under variables, you see that the job, which is the project folder, is addressing to the folder that I created. And on desktop, you will see that Houdini projects, rigid body fracture, all those folders are there, and imported is there as well. So it's a very nice and neat way of organizing your work. So I go and grab that cup, cut it into imported here. Okay, so I'm gonna bring it in. So we start, I'm gonna bring it in, and I'm gonna make it fractured in different ways. First, with a classic Voronoi fracture, which is like Voronoi is the name of a person who created that algorithm that fractures your object. So we use that, and then we move on and use a more recent RBD material-based fracture. Okay, so press tab, add a geo, pretty much like everything else. So we are creating contexts in Houdini. Contexts are like islands of working environments. Like we are working on sub-level, which is surface operators. So I call that like, I don't know, my object here, or my cup. Inside that, press tab, called file, and go find your, so you see that when I click, it suddenly directs me to that folder that I created. And inside imported, my cup is there. Okay, so it's massive. The reason is that, okay, Houdini looks at, so Maya is very metric, looks at the Maya unit system. If you click on this little running guy, so you got the settings here, and your setting in Maya is centimeter. Each one of this is 1 centimeter, but Houdini says each one of this is one unit. So if it would be a meter unit, it will be like massive like that, but that's okay. So you grab the end of your, so you want to transform and scale it. You grab the end of your node, press tab, type transform, and scale it down. So why I can't see that? So there again, Houdini works very well because it helps you to have flag on different, like visibility or like bypass. So when you hover on any node, you have multiple flags. So one of them is visibility, one of them is bypassing, freezing, and information, whatever. So I can't see it because I'm not seeing it. I'm not looking at it. So when I click on it, so maybe I 1/10. That's spacebar F frames the selected. Okay. So that's my object. I might want to move it up because I'm gonna throw it on the floor. So like I go and click on this little icon, transformation. Okay, so that's my cup. So and then this is key, important as well. At the end of this, I add a null. I press tab, type null. What that does? This is a nothing. It's just an indicator. It doesn't do anything. So it's just like something that you use to tidy up your network. I call it art_geo. It means that, and I can like even change the shape and color. I like to always change the output nodes to dark gray. This is my way, but just you can do whatever you want. I would like to turn them like a portal shape because it says, okay, why I add that? Because anything has happened here. So later on, I use this pointer. So if I create like a dynamics, I point to this. So what the hell you do here would be reflected to that pointer as well later on. Let's say we're gonna start going into a new context, which is a dynamic environment. I type dot, dynamic operator environment. Press tab and type dot. Add a dynamic operator environment and call it like cup fracture simulation or whatever you like. So this, okay, when I get inside, there's nothing inside in this environment. First, so this is a surface level environment. This is a dynamic level environment, isn't it? So these two environments should talk to each other. So first I say that load that object. I press object and or I type RBD packed geometry, RBD packed object, and so here I can say that, okay, where is your object? So here you see that it says sub path or surface level operator. You can point to that art_geo, isn't it? And you see that if I connect that to the output, you see that it shows up. Okay, so for a simple dynamic operations operator environment, you just need to bring your object in. You just need a rigid body simulator or solver. You need your object. You need a brain. So like if I add a brain, I have my object. I have my brain, a solver, but it doesn't do anything because there's no force here, and you need some force. So type like gravity or wind or whatever you want. So I added your object, a solver that calculates the simulation, and a gravity, and that's it. So your object has to fall, and the reason it doesn't fall is that if I middle click, okay. So because that object has not turned into RBD. Okay, so here I'm gonna to the pack geometry. I'm gonna talk about how data flows through. So if you remember, I like to close this one and press tab P on anything that I like. So here you see that like this object has 170 primitives, which is like 170 faces, isn't it? Each face is a primitive. If I click here, if I select them and try to move them, you see that an edit object, edit node is added here. Oops, nothing. But if I want to have lots and lots of, how much of memory is occupied? So when you middle click on a node, if you have to middle click on a node to see these ones, or if you click on this like information flag. So this like object is outputting normal map or normals, face normals, and positioning of each face, and it has a material actually, and some UV mapping. So these are the information that this object is carrying. And also this is also important, the memory that this object occupies. So it's like occupies 155 kilobytes of the memory. If I duplicate this object, so if you press tab and type copy and transform and drop it in the middle, yeah. So if you press P, if you can like play around with the amount of copy that you have here with the setting, or press P, or just look at the parameters. So like -2, and I want like 10,000 cups. So it's thinking a bit. Okay, so that's 10,000 cups. I can click on the visibility as well. You see? So bless you. If I middle click on that copy again, it's 7.5 million primitives, and it has occupied 1.3 gigabyte of memory. So I suddenly, with a simple object, I kind of like consuming all the resources in my computer. But before that, before like copying, if I add just a simple node called pack, what this node does, it actually mirrors, instead of like duplicating the entirety of your object, it mirrors your object. But it just like the visibility is pretty much the same. So if this one is 750 primitives, this one middle click is 1 primitive. So all your object has turned into a 1 primitive, very so if you know instancing in Maya, this is something equivalent to that. So now in this copy node, you see 10,000 primitive, pretty much like we said that duplicated 10,000 times. Now I've got 10,000 primitives because I packed it. These duplications are a mirror of the main object, not like an object on their own. So that's why I just, instead of 1.3 gigabyte, I have occupied 3 megabytes of memory. Much more efficient. I bypass this one for now. So let's go back here. So now the object drops as predicted. I have my so you understand this naming now. RBD, rigid body dynamic, packed. It means that this object is already being packed, is already turned into an instance I use the pack node early on, and it's an object. The brain calculates and gravity, but I need it to drop on something. So I press tab and type ground plane. So the ground plane is added, but it has to merge with the rest of the network. So I press tab and type merge. And I add these two together. So there's like kind of like which one should affect the other one. So there's like this discussion on this merge node. If you press P, you can see left input affects right. But I just like go to mutual, so both work with affect each other. And I just turn on the visibility of the ground just so we don't see it. So it's there. It's there. I just say that do not display it to me. Okay. So it drops and it falls on the ground. It's too fast because it's not real time. I click on the real time and I play it. Okay. So now what happened? I have my object, which is packed, and I have my simulation environment. So I have my surface level environment and simulation, but I want to fracture the object. Okay, this is where the fun begins. So here, before the pack node, I want to fracture it. So I start to fracture it the classic way. I use Voronoi fracture. Press tab and type Voronoi fracture. Voronoi fracture, I assign it and it just goes some errors. So whenever you see errors, just middle click and say not enough sources specified. It means one of these is disconnected. It says I need some points to be able to fracture it. So this is your object. You need to say that, okay, fracture from here and there and there. Or you randomly scatter some points on the surface and then fracture it with that one. Just type scatter here and assign to it. If I click on the scatter, you see like, oh, I've got 1,000 points on the surface. But you can have, press P, you can have like 10 points. Can you see those 10 points? So if you press D, I think I can, or I'm gonna turn off the grid. Yeah, those 10 points. Okay, I've got my points, and I say that, okay, use these points to fracture it. So you see that it's fractured. If you want to visualize the fracture, just in the parameters, click on this little map icon, and it just like, this is not a material, it's just for the sake of visibility. So these are the fractures that has been used to fracture my my surface in a Voronoi algorithm. What is Voronoi? We'll talk about that later. So, but this pack node doesn't work on this anymore because that was packing one single object. But now we have multiple objects grouped together on working together on one side like in an attached way. So instead of pack, at this times I use another node called assemble. Assemble means like bring them together and if you go to the parameters, it says that create pack geometry and turn them into pack geometries. If I double click on this assemble, you go to like a very weird environment, which like what the assemble node is just a bunch of like different nodes working together, and there's a pack at the end. I press U to go up. So it's basically a pack. It packs packs your geometry. And the beauty of adding that node here, you see, we fractured our object and we repacked it, and our simulation is there as it is. So now the simulation, and again, you see, this is the non-destructive kind of network. The same simulation, the same everything, and the same load objects properties, they all apply on the new setup. So it packs, it breaks apart. Okay, so that was like, let me add just some wireframe on the surface. Oh, okay. That was just a very simple like setup. A very simple setup. So now what I want to do, I want to like show you what's wrong with this before going to the material-based fracturing. If I move it like high up, so if you see, most of the time Houdini transformation coordination is object-based. It means if the object is oriented that way, the transformation handles point that way. But if you need like word, it's pretty much like in Maya. So in Maya, when you have like handles and you rotate it and you press, so you see that it's because if you press W, it's on the object level. But if you go word level, it's just, it doesn't look where the object is oriented. It looks at the word coordination. So what to do in Houdini, press M on keyboard. Okay, I just wanted to like move it up, move it high up, right, very up, very much high up. So now I play this. I'm going to have to go to this. Okay. There's an issue here. It starts to like, you might not notice, but so it starts to fracture early on, and it just like all the pieces are like very loosely attached to each other. There's no, so there's just like, it means that it seems that they are pre-fractured and just like somebody is holding them together. It's not like they are glued together. Now I want to glue them together. Let me bring it down again. Okay, so if you just want to use shelf tools, I'm sure that many of you have clicked on this glue adjustment. So like it glues the pieces together, so they don't fracture like loosely. There's like some connection between them. I want to create that glue now with a sort of with the nodes structures. Okay, here so that's my output geometry, but I want to like I create another output to use it for the glue constraints, a constraint that glues pieces together. I call it so I use this node, connect adjacent pieces. So what this node does, if I click on it, you don't see anything. If you look at the attributes, it creates, it says that I'm gonna look at your like pieces. So there's a bunch of pieces here. Where it is? There it is. Sorry. Spacebar F. Press W. So there's a bunch of pieces, and it grabs them, and it just starts to create. You see, starts to create some links, some connection between them. So when I increase the search radius, so there's no, it's pretty much like Voronoi again. If you just get inside, it uses Voronoi somewhere. Yeah, I don't know. Never mind. It uses Voronoi to just like find out the pieces that sit next to each other. And then I increase the maximum connections. So when you are happy with like the amount of connections, so this is the beauty of Houdini. You can click, you can view this, but see the other one as well. So the visibility is on this one, but the selection is on the assemble node. So you see that how different pieces are like kind of connected to each other. This is nothing, it's not connected yet. This node does anything just but creating these like lines. And if you look at attribute spreadsheet, you see that like the pieces have a name now. Piece 0, piece 1, piece 2. So this like has created those like names. Actually, they have been created early on here on the assemble node, but they travel to these connect adjacent nodes. I make a null out of that. One important note is that like the commonly used nodes come to this history part. So I add another null here. I turn it into the shape of what I like. C is for bringing that color, and I call it out glue. So I'm gonna use that to glue the pieces together. Okay, so what should happen inside your network? You need a glue network or a constraint network. Inside I type constraint network. This network, oh, give me an error because it needs a, so do you see that little red dot? It means this is a must. You need a constraint to create. So first, before bringing that, I said that, hey, SOP path, you need a path for the glue, so the constraint. So this path out glue is what you use for your constraint network. And it needs a glue constraint here. So you see that glue constraint relationship. But still, it doesn't work because this glue constraint uses a data name. This is the name thing that I wanted to point at. It uses a data name, and that data name should come from this glue network. I go up again. Here I'm gonna create a name. So like these pieces, they don't have a name actually, these like lines. I create that name. I want to create a new attribute. It's pretty much like in Maya. I'm sure many of you have created attributes. So let's say you wanted to create an attribute here. Here you said that I'm gonna add an attribute. Then Maya says what attribute? So you might say that like color. And come on. And then this is gonna be float or integer or a string. So like these different options, and then you create that attribute. You create a maximum or minimum for that. So here a node can do that. Type attribute. So attribute create, or actually that one. So you create it, click it here. You say that the attribute that I'm going to create is actually my constraint underline name. The name of the attribute that I'm going to name them is constraint names. It's going to be on primitives. It's going to be string. So you know the difference between these three. Float is any number. 1.6 is a float. Integer is like incremental numbers. 1, 2, 3, 10,000 without any without any what do you call it? Decimals. Yeah. Vector is a combination of 3 numbers, and a string is just a phrase. Here I call it like, I don't know, cup glue. So the constraint is generated, and I'm gonna use it in my dynamic network. I get inside here. I called it cup glue, isn't it? So now I hope that it reads it. So let's see. So you see that now the pieces are glued together. They don't easily break, and the strength of that glue constraint is here. Strength. It's 10,000 now. Like let's make it 100,000, it doesn't break at all, I'm sure. Oh. Here there's some issues here that I will explain you what are them. These issues come from Voronoi fracture. Actually, Voronoi fracture is not happy about like this convex environment. If you select your Voronoi fracture, and there you can choose different way of fracturing it, but that's okay. I will for now, but let's leave with that. So you see that they are glued together until like they, so, or you can say that the gluiness would be like very loose, 100. So it breaks apart. 1,000 was fine. Just some pieces break. Or 10,000 maybe. Okay. Now, so now you saw that we created, we fractured our object, assembled it, created the glue constraints, connected together. But what if this, so like a couple of important questions. First thing first, let's go back here. I'm gonna click here. So let's go back here. First thing first, if you see that scatter node, the points are scattered on, so if I bring it like 1,000 points, you see that all the points are scattered on the surface of the geometry, but you want them to be inside the geometry. So let me just go 10,000 again. So that's why sometimes you see a iso offset node, which is basically nothing but converting your geometry into cloud, is added. So this iso offset node converts your geometry into cloud, and this cloud is just like, if you like increase the sampling, you see that, oh, that's my cup, but in a cloud format. So if I feed in that cloud into my scatter, those points now occupy inside the geometry as well, not just the surface. So the fracturing is happening, uses those points inside. That's one point. So like, let me just go for, well, let me delete that one. So another question is, what if I want, so let's say, oh, that's 10,000 fracturing. I should have not clicked on that. I press escape so it doesn't calculate. I go back here. So I kind of like stopped Houdini from calculating. So I make it like 100. That's better. Okay. So you see that like it has fractured 100 pieces. Oh, that's terrible here. I should say that. Anyway, I should have done a better modeling here. Actually, I can fix it here. I can go back. Again, proceduralism. So everything is reversible. Let me hide that. I'm gonna add a, so grab a, press C snapping to curve, isn't it? And just create a curve that attaches here. Okay, and I attach these two together, shift right click. What was that? Curve attach. They are attached, but I want that before attachment I say connect instead of blend. Attach. I delete the history, Alt Shift D, and then I rotate this one now. So now I've got an inside part as well. Convert that into modify, convert that to polygon. Put all of this into source, hide them. Okay, that's a nice polygon. I smooth it out. Delete the history, call it cup again. So it says cup 1 because we already have cup. Converted cup old and name that cup. And I export it again. Overwrite the one that I had, but I should make a backup before overwriting it. But I don't, just keep in mind. Make always a backup. So I overwrite here. So what happens inside Houdini? Let's go back to file. So reload geometry. Oh, bang. It just there. Transformed. Look at Voronoi fracture. There's no issue here. So see how nicely we traveled back and forth between apps. Anyway, so what I was talking about, what if you want to say that I want, so this is like evenly fractured all through. What if you want just like some like very tiny fractures here, but like large pieces around? Just use a paint node. Paint here. This paint node is actually, you can say, okay, background, apply, so to all, make it all black, and then foreground is, so this paint node gives you this like nice menu. If it doesn't, just press enter. And say, I just want the fracture to happen here. Maybe a bit inside as well. So like, then attach that to scatter. So if you click on the scatter, you see that, oh, some of these, if I increase the scatter, you see that, oh, some of these are black, some of these are white. So color has transformed into scatter, but the density doesn't. So, but you can click on the density and say that use color. You know that color is CD, color data. Oh, cool. So you see that it just created points where the color is. So I go back to like 100 and look at Voronoi fracture. So just that part. So this is like an old method like to manage your fracturing. So that was a couple of notes. But what if you want to use the new material-based fracturing that is introduced in Houdini 17? So if you use RBD fracture instead, RBD material fracture. So it takes some time because that's a very complicated node, and that node doesn't need anything but your object. It doesn't need like points, it doesn't need anything. And by default, it is concrete. So concrete fractures from bottom. So if you look at the setup, it says that it's concrete, and like you can adjust a lot of things like chipping, like details, or you can turn it into glass. Okay, so we're gonna work on the glass, but this is like a very deformed one. So how can I manage the fracturing glass, even though it works on its own, or like wood? If this cup would be a wood. Wood is the most complicated algorithm here, so that's why it takes like a bit time. So yeah, so you see that the fracturing is following that kind of material structure. I'll go to the glass. So here you see, even though it works on its own, but it has some inputs. One of them is, it says like Voronoi points actually. So I can drive it with use proxy geometry or like constraints. So I can drive it with some points. So what if I create a new scatter here, and that scatter would have just one point. So I connect that to here. Well, actually I have to turn it into 1 point first. So if I click on it, you just see one single point in the space, and that's the point. You can even select it. Select that point. You can go here and say points and select that point. But I wanted to do it later. So before, okay. So that just 1 point, come and so. And here, nothing happens because you have to say that input points are there. So you turn it on, it recalculates, or yeah, it actually uses that point to fracture, and then you can move that point around. So I'm gonna go back to concrete so it would be more manageable. Or maybe glass. So it says scatter some points, but not use input point. I just want to say just use input point and do not scatter any points. So that's my point over there. That's this little point here in the space. I go and select that point. If I would be here on the point, and I can move it. The moment I add move tool, and edit node is added. So that's your glass. It's reshaped. I show you how to change it out of. So like I can move that point where I want, and it just like updates based on like my positioning. Or I can paint it the way I like. Okay, so adjusting some stuff. Discontinuity, some discontinuity. Chipping is nice always, but it's a bit expensive in terms of calculating. So because it just like adds does very little, very little details, which is, well, it works very well with concrete. If you have glue constraints, it can be added here. Okay, anyway, then if you're happy, everything can go back to your network. So only your fracturing has different. For the fracturing, you have used a different algorithm instead of Voronoi. So that was Voronoi, the old way, and this is like the new way. Let's make it like a wooden cup. Wood. And wood, but it takes some more time. That's a nice spot to be fractured, and that you see that there's like a very big chunk of wood here. So let's see how this one does the job. Oh, you see that, like, again, that glue constant is there. So like if I go up here in the adjacent points that I had, oh, constraints are there. I just have to turn this off. I'm gonna turn that. Okay. So glue constraint is where the points are getting connected, and now we've got 100 pieces. Okay, where I was, I just wanted to come here. Oh, no. So let's go back to assemble. They assembled. Glue constraint inside that. Okay. So you see that the breaking is following the specification of that material. I'm gonna make it a bit looser because it's wood. So glue constant is like 1000. It breaks like a wood now, not like a glass or concrete. So we've been through all the process of fracturing and how to direct it, how to use different fracturing methods like Voronoi fracture or material-based one, and also how to add glue constraints, which is like your first kind of complicated constraints. Okay, great.